State of the Industry Roundtable webinar. If you have questions or comments, please tweet them, and we're watching the StackScope hashtag on Twitter, and we'll be live streaming those and answer your questions and comments as they come in. Happy to hear from you. My name is Baron Schwartz. I'm with VividCortex, and joining me is Adrian Cockcroft, who's at Battery Ventures and previously at Netflix. Jason Dixon, who's a monitoring guru and at Librato Metrics, organizes the Monitorama conference and a whole bunch of other things. Nathan Harvey, who's at community relations at Chef and organizes the DevOps DC meetup around the Washington, D.C. area. So we're ready to get started. We're going to cover a whole bunch of the things that we are interested in and excited about in 2015 and beyond. Some of the topics are going to include, roughly in this order, containerizing, monitoring, SaaS, microservices, DevOps, configuration management, state of the cloud, emerging languages, and some upcoming events. And the webinar is recorded and will be viewable on YouTube afterwards. We'll post some information about that afterwards. So first I wanted to start off with containerization, and for a brief history and overview of current technology and how we got to where we are, I'd like to turn things over to Adrian.
Hi there. Well, the history, I guess it started with things like BSD jails and Solaris zones and LXC. But what the history really starts about a year ago. If you look back at the analyst prognostications for 2014, nobody really mentioned containerization as going to be a thing. During the year, it really became one of the fastest growing new topics in the industry, and so Docker became very well known. And now if you look at the 2015, same people saying what's going to happen this year, it's all, yeah, there's Docker everywhere. So that's kind of how it's turned up in the market. I think containers do several things for you. One of the things is they speed up the pace of development so that it takes less time to get things done. It takes less time to deploy code and test code. Another one is that they define what the configuration of something's going to be on your laptop in a way that is the same in test and the same in production, so the container contents doesn't change. This is similar to the model that Netflix has been using for a few years with AMIs. So they bake their code into an Amazon machine image and deploy it on AWS, and that would take a few minutes to bake and a few minutes to deploy, and that was pretty good. But with Docker, it takes a second to bake and a second to deploy, so it's that much faster. And the other particularly interesting thing is the Docker Hub. So there's a bunch of standard images in a central place that you can then deploy on your laptop or on test or production or a different cloud. Pretty much any cloud vendor. All the cloud vendors have announced support for Docker, and you can also run it on-prem, and it's the same container. So I think those are the three really interesting. What makes it interesting now?
I think amongst the companies represented here today, probably several of us are using Docker in some way. I'll start first, just say what we're doing with it at VividCortex, and the answer actually is not very much. We have looked at it and we've been streamlining our continuous delivery pipeline in various ways, and one of the thoughts was to use Docker in the typical ways, to build images that we can deploy on laptops and deploy in staging and then just shove exactly the same bits to production and run them. But we ran into some issues around configuring things connecting to the networks. We need to refactor our service deployment system a little bit more so that we have more of a centralized deployment system with service registration and so forth. So there's just a few moving pieces to fit together, but it does seem to hold great promise for us, and there are definitely some current pains around speed of delivery that it would solve. Adrian, Nathan or Jason, anything to chime in there?
Yeah, I mean, at Librato, we've been looking at it, and I think we've had similar experiences. We're probably not as far along the curve as you are, but we're definitely looking at it. Right now, it doesn't make sense for us currently, but we're 100% on the Amazon cloud, so I think it's just a matter of time before we move to containerization.
Yeah, and we use it for some testing stuff similar to what you've described, Baron, and I know that throughout the Chef ecosystem, as folks are building cookbooks and doing automated testing around their cookbooks, the speed with which you can bring up a Docker container really makes that process much, much easier, and you can very easily get into that workflow of doing test-driven development with your infrastructure code. And I think that's a really promising use of Docker and containers in general.
Yeah, I've got, actually, since I left Netflix, the Netflix open source packages, there's about 50 of them in GitHub, and I think it takes months to really figure out enough to get it all up and running. What they did late last year is they Dockerized it, so you can now start Netflix OSS on your laptop in 30 seconds. They've got things sitting in Docker Hub. So you can go and, in a few seconds, start all the different tools, and they're sort of downsized so they use minimum memory so that all fit on a typical laptop. Yeah, they don't suggest you do that in production. But I think somebody said they had actually reconfigured those containers to actually run some sort of at least small-scale production use of a few pieces of it. So it definitely makes it much easier to try something up. That's a good use case for now.
Nathan, I wanted to ask you a little bit more about how Chef's configuration management and Docker interact and some of the benefits and changes in workflow that might create.
Yeah, I think Chef is doing and has done a lot of different things with Docker. I think that we have some tools that will help you build your initial Docker images, and I think it's a really interesting space just to see where the space is going to go. And I think very much like when infrastructure as code and configuration management sort of first came out, there's a big shift in the way you think about things, and just the approach that you take to how those applications are built and deployed. And I think, frankly, we're all still sort of figuring out what's the right way with Docker, what's the right way with containers. And as a result, both within Chef and across the community, there's tooling that's springing up, kind of experimental, different ideas. I don't know exactly where it's going to end up. I think it's a super interesting space to continue to watch, though.
Does it create more things to configure?
Yeah, I mean, I think you touched on some challenges with networking and things like that as you're moving those containers around. I think that there's a tendency, I think, initially to think about containers like just the promise of golden images reborn, at a virtual machine layer. And of course, that didn't work out so well. We know that doesn't work at scale. So it is definitely something that creates more things to configure. You have to configure the base machine that's running the images or the containers, and then the containers themselves. But I think where it gets really interesting is where you get in a place where you can use sort of a configuration management framework to help define what those containers look like. And then some other system, maybe the configuration management system, maybe something else, to sort of orchestrate the management and deployment of those containers.
And what about monitoring, Jason? Suddenly you have what looks like a profusion of virtual operating systems to monitor, don't you?
Yeah, I mean, it definitely adds a new dimension to monitoring in the sense that it creates a lot more moving parts. I mean, in each container, you're going to have basically the same thing. You've got your operating system, you've got your application code and libraries, but now you also have a host OS. And you've got to monitor not just the internal containers, but everything else involved. So, there's still a lot of improvements to be made, at least in my opinion, in terms of the instrumentation and telemetry around there. But it's an interesting kind of cognitive dissonance in the sense that we are kind of looking to containerization because it creates a little bit of order, it allows us to do isolation. On the other hand, it adds a lot of this complexity and more moving parts than we traditionally want to see, at least in terms of operations.
And Adrian, does Battery have a particular investment thesis that includes containerization or things around that space?
Yeah, I think we do. The best way to think about it is if you have a brand new market that appears very quickly, then there's a lot of disruption, a lot of opportunity, and confusion, and that's a good chance for a lot of startups to come in and say, oh, hey, we've got the solution here or the solution there, and touched on a few of the gaps. So far, Docker's pretty mature if you want to deploy a single container and you've got a collection of machines to deploy them to. So that's pretty good for test and dev kind of workloads. When you look at production, you typically want to stitch together multiple machines with lots of different containers and different container types. So there are gaps right now around orchestration, where there's different people competing for who's going to orchestrate it best. And then there's how do you network it together. So there's things like Weave and Socket Plane that are interesting. And then how do you move storage around if you need to. So Cluster HQ is doing some work there, and there's a few other people. So those are the people that most people have run into, I think. And then there's a whole host of startups that maybe some of them don't even have names yet that come parading through our offices going, hey, we're going to solve this problem for the world. And I'd say that if you're in that state, sometimes I see people come in and say, yeah, here's a plan, it looks really good, and says, so we're going to have a beta for this in 6 to 9 months, and we'll have a product in a year and a half. And I said, no, that's not. You don't understand how fast this ecosystem's moving. Right, that doesn't work. It's like, what have you already released? This has got to be an incremental, public domain, open source code kind of thing. You've got to basically get a code release out that establishes a foothold in this space, and continuously iterate on it. And I think Weave is a good example of that. Whatever you think of the technology they're releasing, they really do know how to build a developer viral product that's easy to use, and that's the attributes you need to keep up with the ecosystem play here. So it's been fascinating for us to get involved with it.
Wanted to turn to monitoring next. There are several of us here who are very interested in monitoring. Both Jason and I come from companies that are pretty much built around monitoring, and monitoring is a huge thing at Netflix as well. There's been a lot of discussion in the last few years about changing how we monitor, changing some of the thoughts around the traditional monitoring tools and why they were built the way they were. There's a lot of new open source solutions. Some of them seem to be popular to talk about but not popular to deploy, and then there are the ones that are the exact opposite. Everybody seems to still use Nagios one way or another. So what is different in the mainstream now from, let's say, 5 years ago? Jason?
I think the biggest thing, and I talked about this, a few years back, is kind of the emergence of monitoring as a distributed service. And I think that you look at companies that came up, like Heroku and some of these, a lot of the PaaS companies, that everything is distributed services, whether you want to call it microservices or SOA. And all of a sudden now you've got all these discrete components, and you really need to monitor each of those individually and in their own special way. And so I think you start to see a lot of these small, sharp tools in the traditional Unix model that evolved and got released as open source, and people really latch on that because you can't have, in my opinion, one large monolithic tool to monitor all these kinds of architectures. You really need those small sharp tools that can be deployed easily, that can be scaled independently, and they just all have kind of interoperable interfaces.
You've talked a lot about a composable monitoring stack in the past.
Yeah, I mean, I think for a lot of monitoring architectures, it's really the best way to approach this because, again, there's a lot of unique requirements for these types of businesses, particularly in web operations, where you've got a lot of moving parts and a lot of interfaces naturally anyways, because you're using queues, you're using buses, so it helps to have the kind of, the systems that can also speak that language, and it just kind of naturally evolves into, the monitoring requirements.
Mm-hmm. And Adrian, your thoughts on this?
Yeah, there's a lot of activity in this space right now, and there's several different ways of looking at this. The open source tools are getting better and better. One of the companies I'm working with is just started installing Grafana, Graphite, Sensu, and they seem pretty happy with that. And you've got one guy that seems to know what he's doing and is configuring it, and that gets you a fair amount of functionality without buying into a vendor. Then there are vendors who are saying, well, I've got an easier to install or a better version of Graphite or a better version of something else. And there's a whole lot of traditional vendors that have been around, 10 years or more with products that kind of generally look a bit clunky nowadays. And then other vendors that really specialize in different areas. So people are trying to solve, a lot of people have they're trying to solve the same problem, but they're coming at it from different positions. The most interesting stuff, I think, is where people are doing, making sense of the data. What analytics do you have? I don't just want to see graphs. I want to see histograms of response time distribution. I want to see just from more than just strip charts. And I want to see analytics that will tell me what's gone wrong and maybe have lead me to the solution, rather than just say I have somewhere in this several hundreds of thousands of metrics or millions of metrics there is one that's bad, and maybe I sent you 1,000 alerts because one machine went down, and it's spread out. So how do you correlate metrics? How do you make sense of that stuff? I think that's an interesting emerging space.
Yeah, a lot of that kind of falls under the rubric of anomaly detection in one form or another. And that's been an interest of mine as well, but almost more academic than in practice, because at VividCortex we don't really do anomaly detection in the ways that are being talked about. And our sort of, if I can put in a shameless plug, our unique take on it, the different angle that we approach it, is that performance management is more valuable than monitoring, that it's more important to know what work systems are doing than what metrics they're emitting. So that's kind of, just a, if we drew a Venn diagram, the vast majority of it would overlap, but then there's that little niche where we think about it a little bit differently, and so does everyone.
Yeah, I mean, just knowing how much the CPU usage of a box is not really interesting now. The kind of metrics that Netflix was collecting, they open sourced from some of their tooling, which is called Atlas, which is, think of it as sort of a bit like Graphite, but with particular being able to run at some ridiculous scale for monitoring billions of metrics and things like that. There's a lot of why there's so many metrics for Netflix. It's got, every Xbox in France is a metric, or whatever. So everything is sort of sliced and diced by country, by device type, and then you've got the response time of a particular call that's going, things like that. So that's the sort of stuff that gets your metric counts up when you go beyond looking at just system metrics, and you've got things that are much more interesting to the business as the things you're managing against.
Yeah, and I wonder, since we started talking about containers and then we've switched to monitoring, I wonder how much the speed with which you can spin up and down containers, how much that affects what you actually care about in your monitors. Like, you probably don't care about the CPU. If you find yourself spawning lots of new containers and containers dying, how much do you actually care about that? I think, is there a risk that because it's so easy that you can stop worrying about maybe the root cause and sort out what the application maybe is doing wrong, and just continually just spin up new containers to handle that demand?
I think we're seeing that. If you see kind of the logical extreme condition for containers is actually AWS Lambda, where you spin up a container to service one event, one request. It basically runs a single node.js request, and then the container disappears again. And AWS are going to charge by accumulate by the 100 milliseconds. So as long as you've got 100 milliseconds worth of activity, they charge you for that. So that node container, I mean, it's just what you give them is the node script. There is no monitoring agent in that machine. There's, they accumulate how much it used and tell you later how much you can. There's some CloudWatch metric, I guess, for it. But that in that environment, you've got a very dynamic system. It's actually interesting just think of it from a security point of view. How would you even have a break-in to a system that only exists for a few hundred milliseconds? So it's in a sense a very secure system, but again, some new monitoring challenges. And how do you think about that kind of system?
What kinds of new tools and stacks are we seeing coming out in open source and in closed source, for that matter, or in services and platforms? Jason?
I mean, there's the ones that I think a lot of us are used to. I mean, I'd say that probably the newest, most interesting one is probably Grafana, which is it's a visualization dashboard. But what makes it unique, unlike a lot of the other Graphite dashboards or OpenTSDB dashboards, is that it largely aims for an abstracted backend. So you can use Grafana with a bunch of different time series database backends. So that's pretty unique, and allows a lot of people to kind of use that same interface and have that same shared experience, no matter what they decide to use on the back end. And that helps a lot, because there's a lot of stops you see people using OpenTSDB because they have, say, a Hadoop experience. A lot of places don't have that. And on the other hand, a lot of people use Graphite because it's easy to use, but so you've got that. I think Riemann is one that continues to kind of fly under the radar. I like it a lot in the sense that it's a really powerful state engine. It does metrics routing really well, and it just happens to be written by the same guy that released Jepsen, Kyle Kingsbury, and he's a brilliant engineer. So I'm a big fan of that. I think the one thing that's kept it from gaining more adoption is just its closure configuration in DSL. I mean, I kid about it, but I think if someone came out with a Ruby DSL, it would probably increase adoption, but tenfold overnight. I think Graphite continues to be very popular in terms of open source stuff. I'm actually a developer on the project. We're currently in the process of cutting a release that I actually happen to be also writing a book that targets, so I'm pretty excited about that. I haven't mentioned a lot about open source or time series. I should just mention one more, and that's InfluxDB. That's kind of been like the darling of open source over the last year or so. It's kind of unclear as to where they stand right now. They gained a lot of adoption, but they also had some issues with scale and clustering support. So I know they're in the middle of a rewrite, but it's definitely a project to keep your eyes on.
I think that's written in Go, isn't it? Is that the one?
Yes. Yeah.
And Adrian, what about the things that Netflix has been releasing? Which of those are being adopted and seeing broader usage?
I've been out of there for a year, so I don't have. I mean, you could look at the GitHub repo counts for how many times people have been downloading them. I think the Netflix has been. You can take it piecemeal. There's a bunch of interesting standalone projects. There's a bunch of pieces that people have taken. Some of them actually very interesting projects that they released last year around security. And Security Monkey is a standalone product which you can point at a bunch of AWS accounts, and it will tell you if you've got misconfigured IAM roles or security groups or S3 buckets that are wide open to the world. And it'll basically say, no, this shouldn't be in this state. This is too, it's got a bunch of knowledge about what an insecure state would be. And then you can whitelist things if they're supposed to be that way for some reason, and it's got ways of managing the workflow. I think there are actually some companies trying to sell products like that, but there's a nice open source thing sitting there. So that's a standalone thing. It's got nothing really to do with the rest of the Netflix infrastructure. It's built as it's a Python app running on top of Postgres, I think. But
I must say, if I could add one thing about the Netflix project. So you take Atlas, for example. One of the interesting things I see about like the Netflix open source and Twitter open source isn't so much that they end up seeing huge adoption, because I mean these companies are at such a large scale at one end of the spectrum. It's hard for the average business to kind of adopt a lot of these tools. But what I do see is I start to see patterns in terms of, like, you look at companies like Netflix and Pinterest and some of these, and in particular time series data, they've achieved such scale that they're no longer concerned with actually storing the stuff, storing the archive in such a way that it can be quickly retrieved. Like, they're only interested in in-memory metrics for some period of time, and after that they don't even care about it anymore. They may aggregate off of it, store some of those the important long-term metrics in S3. But you're not going to see systems like Graphite and OpenTXDB built in the future that really emphasize long-term, 1 to 2 to 3 year retrieval. I'm kind of curious what you think about that, Adrian.
Yeah, I think that's true. The Netflix model, because they're driving there's so much intense activity pulling data out of the system that in effect it all has to be in memory, and they store a week or two's worth of raw data in memory, and then they summarize it down. But it's largely an in-memory system. And
yeah, I'm curious how that's going to apply. Oh, I'm sorry. I'm curious how that's going to apply to containerization later on. I mean, we talk about how transient these containers are, and how that's maybe going to apply.
Yeah, you have to accumulate you have to group together a bunch of containers or instances into a service or whatever, and you do most of your metrics at the service level. What is this service doing rather than what is that particular instance doing? That's generally how you think about it.
Jason, we've talked about a bunch of things, but you've never really said much in this call about what Librado does and where it fits into the monitoring landscape. Maybe we can end with that.
Sure.
Move on to.
Yeah, I mean, like I said, I've been a Graphite developer for a long time. If you're familiar with Graphite, I mean, again, you probably know it does time series graphing and things like that. Even before I started Librado, I was always kind of a big fan of the way they approach the problem. They understand that time series is it's challenging to scale. So they built a Graphite-like service for people who don't necessarily have the expertise or time or interest to build it themselves. graphite's hugely popular because it makes monitoring with time series accessible to a lot of people. And I've always kind of viewed Librado as very much like that, without the headaches of scaling and maintaining your own cluster. So I mean, there's again, if you're a fan of graphite or OpenTSDB, I think that Librado kind of naturally fits into that same area of the landscape. It provides this interface to storing your metrics and retrieving.
The graphite tends to be pretty heavy on servers and pretty hungry for horsepower, doesn't it? So it's scaling your own clusters.
I think that's largely true of any once you get away from anything, like I said, the newer ones that use just memory, I think that's true of any of them. I mean, we can talk about Influx using BoltDB or LevelDB, but at some point down the pipeline, you've got to write this stuff to disk, and there's going to be that I/O debt to pay, which is a question of how and where you pay it. So.
I think
no question.
If you look at something like Atlas, it is not a cheap system to run. It's the way it is because that's what they could get to work, and it uses a lot of memory. So if it would be much cheaper to put that stuff in disk, but you wouldn't be able to summarize metrics out of it in the way that with the power and expressivity that Atlas has.
Yeah, we struggle with the same kinds of things, I'm sure, that everyone else does here at VividCortex. I gave a webinar last month about how we built our time series engine on top of MySQL. By the metrics, we've done a pretty good job compared to other things that are available in the market, but it's still expensive. That's a lot of data. We collect everything in 1 second resolution, so there's a lot of data. Well, this has been very interesting, and I'm running a little bit behind where I planned to be in the agenda, so why don't we skip over SaaS and microservices to some extent, because we've talked about a bunch of it in some detail, and switch to DevOps and configuration management. And for that, I thought I would ask Nathan if you can just introduce us real quickly to what DevOps is, and maybe Adrian after that.
Sure. So when I talk about DevOps, I really view it as a cultural and professional movement that's really about getting various parts of the business working together to deliver that customer delight, and it really is about continuous improvement, continual learning, and again that collaboration that's so key. And of course, there are people, there are processes, and there are tools that all sort of help guide what that journey looks like. And I think it is a journey for each individual company. The journey is a little bit different, and there's so many different paths towards DevOps. I think that a lot of them sort of lead towards continuous delivery as sort of an outcome or a goal that folks are looking for. But yeah, I think really at the end of the day, for me, what DevOps is about it's about the people working together. That's the key. That's where it starts for sure.
Adrian.
Yeah, there's several different flavors of this, and I think you can come at it from different viewpoints. If you start off from the operations viewpoint, what you're really trying to do is automate the operations things and build something which really integrates well into the development process, and that's a lot where Chef came from, and that whole process has got very effective. But you're basically building APIs that let you control and automate the operational thing, and you're coding up what it takes. Infrastructure as code is kind of where Chef came from. Point of view. So Netflix came at it sort of from the other end, where the development people basically were looking at, well, we want to, if you're doing continuous delivery and you're releasing code multiple times a day, you don't have time to have a meeting with ops to explain what you're doing. So you have to own what you're running in production. So there's this run what you wrote thing, which Amazon has sort of promoted and which Netflix went along with. And so from a developer point of view, now own everything in production, you're looking for tooling to solve that. So you build some kind of platform. Again, it may be the platform that a cloud vendor built, or a platform your operations team built with tools like Chef to do it, but there's some set of API-based interface between the two. Then the third thing is that rather than this being about tooling, is the cultural aspect of it, which is that for a lot of companies, really the place where you start with DevOps is with a reorg. If you have teams that are very siloed and separate, you can ask them to talk to each other, but it doesn't necessarily help. But what we're seeing now is quite a lot of people taking maybe 6 months to a year as the start of their journey, is they're actually merging the team. So you're getting combined dev and ops teams in one organization or one series of organizations, where each team that's building a microservice has the developers, and they have the operations people, and they have the product manager, and they have everything they need, QA, whatever they need to get that thing in production and keep it running. And that is, and they have APIs to that thing. That's kind of the microservices model, which really forces a DevOps transformation as part of the whole thing. So this is how continuous integration drives DevOps, and microservices as the architecture. They all sort of tie together, and that's why there's sort of an interesting discussion going on in the industry now around that.
Nathan, you talked about this before, and Adrian just mentioned it, infrastructure as code. What is that?
Yeah, so infrastructure as code really for me is a couple of things. Number one, it's the ability to provision and manage the configuration of your infrastructure, so the servers on which your applications are running, and manage all of that through code, which of course means that you bring if you look at the history of sort of the sysadmin role, we've all known the system administrator who lovingly built a server who you're not allowed to touch that thing because I built it. It's my bespoke system. I am the only one who understands how that thing works. And so moving away from that into a place where we can actually codify what those systems look like. And like Adrian said, it's all about exposing APIs and building APIs around things, and so you can so that you can manage all of that like real code, like you manage your applications. And I think that it's really interesting to see sort of the folks that approach that, as Adrian mentioned, right? You might have developers that are approaching that. You might have operations people that are approaching and building out that infrastructure as code. And I think that we can, on either side of that fence, if you will, you can learn a lot from one another. A developer can learn a lot more about what it means to have applications running in a production-like environment, not just running on a local laptop. And at the same time, the operations folks start to learn a lot more about proper software development practices, things like putting your code into a proper version control system, doing things like test-driven development, things like that. And I think that really infrastructure as code is really about enabling all of that. We saw with the Agile movement a big focus on developer productivity, and I know I've been at, worked at, and seen many places where the developers are basically developing applications faster than the operations people can move them into production. And so infrastructure as code is a good way to get you started with that automated provisioning and configuration of those environments so that you can move towards that continuous delivery.
And isn't it really, it's crucial for continuous delivery, isn't it? I mean, it's not optional.
Yeah, it's definitely not optional. Like, just like a proper version control system is not optional, right? If you're not using a proper version control system, don't think about continuous delivery. Think about putting your stuff in Git or whatever your version control system of choice is.
And Adrian, we know that a lot of small companies and medium-sized companies have been very successful with it, adopting a DevOps approach. And you work a lot with enterprises, don't you? You're helping people see how to adopt it within much larger organizations. Can you talk about that?
Yeah, we're seeing that quite a bit. Just from the Netflix OSS point of view, probably the two biggest companies that adopted the Netflix OSS platform almost wholesale were IBM and Nike. IBM's Watson services run in the Netflix sort of microservices architecture that's built out that way. And then there was a presentation at Nike from the people who did the back end for the fuel bands and things like that. Literally Internet of people running around kind of things. So from that point of view, people are figuring out, okay, we like the agility, we like the scale, and we like the ability to build applications in that way. I think the DevOps Enterprise Summit last year was a real eye-opener. It was the first time the conference was held. In the end, there were so many applications that really the whole conference was end users talking about how they use tooling and how they were going through these transformations and what they were doing. There were very few vendor pitches. Most of the vendor pitches were actually the internal organization of those vendors and how they were doing internal sort of DevOps transformations and moves to continuous delivery. I'm actually in Virginia today. I spent yesterday talking to people at Capital One who are going through this DevOps transformation and trying to build a really agile and innovative culture in the financial industry, and hoping to be disruptive and just move faster and get things done in more interesting, newer ways than most banks have historically been able to do. So that's been an interesting sort of opportunity to get to know what the real problems are in this space. And they're fairly early on in the process, but they are definitely trying to get to, and they're considered most of the places where I do talks, I call it baffling late adopters as a service. I'd say what was happening, the interactions I was having yesterday, this was an early adopter, and it's actually more challenging for me to try and think a little bit further down the road than a lot of the people I interact with.
What kinds of management techniques and changes to management techniques and philosophy are you seeing as a result of that? I've heard people talk about like our traditional corporate structures were kind of built in the early 1900s, or sometimes people even refer back to the Middle Ages.
Yeah, I think that you're seeing a lot of the old way, sort of traditional hierarchies breaking down, so you get much flatter organizations, and you get, instead of being organized across skill sets, so you've got the sysadmins in one group and the developers in another group and the UX engineers in another group, your group is involved in delivering a piece of the service. So in Netflix terms, like the group that says this movie is similar to these other movies, you see that row on the website, there's a team that builds has an API. You give it a movie ID and a customer ID, and it gives you back a list of movies optimized for that customer. Behind that is a whole lot of AI, a large team of people that have been optimizing that algorithm for years. But that is a team that just has an API that plugs into the rest of the system. So that's, I think, the sort of organizational change. I think you're also seeing, just going back to Capital One, they're saying, okay, we're thinking of, we want to set up an open source program. We want to have stuff on GitHub. The kind of developers we want to hire are people who have open source projects that are interesting, and we want to breed those internally. That's something Netflix went through, and they were sort of asking, how do you do that? And that's a very different position from a bank. I mean, they're still, they are actually presenting at the DevOps Enterprise Summit, but their corporate communications people wouldn't let them post the video. Okay, so still working on that a little bit, but those are the kinds of things where if your corporate communications people are really controlling how you can engage, then you've got a little bit further to go, but they're actively trying to knock down those barriers and move to a model that is much more open and basically leverages and creating open source. And you're seeing that across lots of companies. You're seeing that at sort of Nordstrom and Target, the Department of Homeland Security. Those were all presentations you can see at the DevOps Enterprise Summit. They're all on YouTube.
I saw one here locally from a very large company, a Fortune 100, just last week. And the speaker was compelling and engaging, and I thought, what a wonderful presentation. And people asked for the slides, and he said, I can't do that, I would get fired. Yeah, so there's a very different, there's a lot of cultural shifts that are going around this change.
Yeah.
Why you see the trend of people breaking out their cell phones during presentations and snapping pictures of every slide as it goes by.
Yeah.
Everyone gets the slides.
Yeah.
Yeah, exactly. Yeah. This kind of leads naturally into another of the topics about cloud and the state of the cloud and kind of where we are. It's the year 2015, and in the year 2010, 5 years ago, I was a cloud skeptic, and particularly as a database performance expert, I was seeing nothing but problems from people trying to run database workloads on the cloud, and I said, this will never work. Everybody will always run their databases in their data center and everything else in the cloud. And here I am, founder of a startup that's completely cloud-based and heavily data-driven with very demanding database workloads. What are we going to see in 5 years that we're skeptical about now? And I guess I'll start with Jason. Do you want to take that one?
Oh wow! Part of me says, I guess the old man in me says that people will never trust adaptive fault detection because there's this layer of trust that you need to have in the tools you use, and I think that a human's always going to need to be involved in that. With that said, like people were saying about the cloud 5 years ago, it's never going to happen. So I don't want to say never, but clearly there's a lot of push from companies like Metaphor and Grok, people that are a lot smarter than I am, investing time and money into the idea of adaptive fault detection and anomaly detection. So I think that's probably where we're going, but it's still too early to tell.
Adrian?
I think there's a couple of things that are coming. The closed loop control system, I think, as soon as you close the loop and you put your monitoring system feeding back in and controlling what's going on in production, I mean, it's so easy to shoot yourself in the foot, right? You've seen a sort of autopilots and, you know, cruise controls on cars. I mean, if you're not paying attention, you just crash into the car in front, right? So what you have to do is think about your monitoring system as a critical part of your infrastructure. It has to be more reliable than the rest of the system. It has to be more highly available than the rest of the system. So this has been one of the things that sort of people have been gradually adopting, things like autoscaling. It took Amazon quite a while to get the Amazon autoscaler reliable enough that Netflix, after several years of using it as sort of manual knob that we turned, we actually did the feedback loop and started actually controlling it directly. And had enough confidence that that wasn't going to blow up occasionally. So I think that you're seeing a few people doing it in a few places. I think in 5 years you'll see lots of, you know, not just right now. There's lots of automatic repair systems. You know, machine dies, you automatically replace it. I think you'll see auto-scaling, performance tuning, and anomaly detection and repair coming in that sense. So I think that's closing the loop and getting monitoring systems to be really highly available is a key thing that hasn't happened yet.
I will say I don't think that we're going to be ready for automatic remediation even in 5 years. I don't know if you guys follow John Allspaw, but he made an interesting post recently about the fact that as humans, we still don't understand ourselves well enough. So how could we possibly program computers to do that for us?
Yeah, I remember seeing that tweet. It was just a couple of days ago, wasn't it? It suggested that we learn how we make decisions before we try and program computers to make the decisions for us. Yeah. Yeah.
I'm more optimistic than that. I'm seeing sort of better progress for doing that. And a lot of it comes down to breaking the system into small components, which is part of the microservices thing. And any individual microservice, you can reason much more clearly about something when it just does one thing and it's a really clear boundary around it. And one of the problems when you have large monolithic applications is they break internally in very strange ways, which are hard to reason about. So some of it's divide and conquer.
Nathan, your predictions?
Well, I think that you know, as we talk about these auto-correcting, auto-healing systems, and even as we talk about automation in general, I think that there's still a lot of sort of animosity between the folks that are responsible for audit and compliance and the folks that are responsible for automating things, and a lot of mistrust. I'd like to say that in 5 years we're going to solve that problem. Or we will have solved that problem, and they'll be working together. I also think that you know, the trend of enterprises starting to really embrace open source, that it means a lot. I think it's super exciting to see folks like Nordstrom, who, you know, 6 years ago they would never do anything in open source, and today they encourage all of their engineers to participate in the open source community. There was a presenter recently at DevOps DC who has some great stuff that he's built, that his team has built, and they want to open source it, and their general counsel simply won't let them. But the encouraging thing there was that the company's attorneys have hired open source attorneys to help understand what it means to open source some software. So there are attorneys paying attorneys to sort out how do we actually do this without losing all of our IP. So that's pretty encouraging.
Now, who gave them approval to go out and talk to the open source lawyers? That's what I want to know.
Yeah, I think actually the first stage that Netflix went through on that journey was to get the lawyers to sign up to the Apache Foundation corporate committing license, whatever that thing's called. And that was done very early on because we wanted to put patches in to fix things. And then that became the basis going on for how we thought about it. And then the other thing Netflix does is it does come up with new intellectual property, and it does file patents, and then it files the patents and then open sources the project and sort of refers to the patents in the project. So by using the project, you're effectively getting a license to use the patent it's sort of stating that you won't be sued for using this technology. So it's a way of creating a defensible patent portfolio, but not only one that can only be used for defense rather than for going after somebody else. So I think those are good basis to build that on. I actually want to pick up on something Nathan was saying, which is about audit and compliance and things. The other thing that's going on right now in a lot of companies is there's lots of security breaches. It's a big topic. People are realizing that their perimeter security on their data centers is just not where it's going to be. And I think over the next 5 years, you'll see people building architectures which, because you can program the infrastructure, you can actually build very sophisticated locked down architectures, which instead of looking like something that's got a crunchy perimeter and a soft center, looks more like a bag of marbles or something, except the marbles are ephemeral and keep coming and going. And if you think about trying to break into a system that's built, say, using AWS Lambda, okay, how do you even think about breaking into something where the machines only exist for half a second at a time, and they're running totally locked down Node.js things? And it's like that seems like a very secure basis for building an event processing system or an architecture. And a lot of the containerized automated systems, I think there's an opportunity there in the future to build systems which would be, very, very secure against the current kind of things that people are suffering from.
My prediction in 2020 is that we will see database as a service almost ubiquitous. Mm-hmm. So I'm going exactly the opposite from my curmudgeonly resistance to the cloud 5 years ago.
So you're going to run on Aurora?
Who knows? Who knows?
Should try out your backend and see if that works. Amazon Aurora is their MySQL compatible database as a service. I think that's a good trend as well, particularly if you have containerization. The storage tier is a pain to deal with because it's hard to move the storage around with the containers. If you're running against a database as a service, you just avoid that whole problem. Okay. Yeah.
So the 12-factor app, and I know Jason used to work at Heroku, that's influenced my thinking about how to architect systems a lot recently. But the data part, data has inertia, and so that has some special characteristics that are a little bit more difficult to deal with than other kinds of systems.
Mm-hmm. Yeah.
At VivaCortex, we also are bigger users of emerging languages. All of our backend is built on Go, and I wanted to talk about emerging languages a little bit before we conclude. The startup stack used to be LAMP, and it used to be Linux, Apache, and then some database, usually MySQL, and some programming language that usually started with P, that was a dynamic interpreted programming language. Fill in your P programming language of choice. And that's changed quite a bit. And at the same time, the enterprise stack used to be Microsoft, .NET, it used to be Java. A lot of these programming languages and environments that many of us think of as rigid and formal, C++, so forth. And that's changing as well. The enterprise stack is changing too. And I think Go is actually at the confluence of those two areas where they're coming together. And a lot of startups are using Go now instead of Ruby or Python, and a lot of enterprises are building a lot of things in Go. Just wanted to ask each of you in turn, I guess, start with Nathan, what you're seeing in emerging languages and what you're excited about.
Yeah, one thing that we see in the Chef community is there's an open source project called GoRD, which is an implementation of the Chef client written in Go. So that's pretty interesting to watch. And then I know I haven't played with it myself, but I know Adam Jacob has been doing a lot with Rust lately, and is finding that to be, from everything I've read from Adam, he seems really, really excited about that language and sort of where it's headed in the workflow and the premise of Rust. So I think those are both pretty interesting.
Yeah, Rust is one I keep my eyes on as well, and Julia too. Jason, what about you?
We're actually a Java shop. We use a lot of Ruby for the web stuff and Java for the back-end processing. That said, our large long processing engine is all written in Go, and that does a lot of our handles a lot of our Heroku integration and things like that. So it's definitely it handles a lot of concurrency issues at scale for us. So it's definitely got its place.
I guess I'm seeing a lot of things written in Go nowadays. It's become a standard thing that a lot of the, I'd say like 2/3 to 3/4 of the startups that come through, I typically say, what's your architecture, what's your build system, how often do you release? But just trying to get some idea of where they are in the technology. Are they using the state-of-the-art things? And most of it, I think now, a surprising number of things are written in Go. And then even from people that I didn't expect to be using that. I think there was a comment, actually, I think, that Baron made, which is somebody asked, whenever we were doing a talk together, and somebody asked, well, where do you get Go programmers from? And the basic summary of the answer is you hire a Java programmer, and you let them play around with Go for a couple of days, and by the end of the week they don't want to write any more Java. You've got a Go programmer. Actually, that conversion process is remarkably viral. And personally, I've been writing code in Go. If you go to my GitHub account, which is the same as my Twitter handle, Adrian Co, on GitHub, I wrote quite a lot of Go code on the plane on the way to Virginia. I'm going to write some more on the way back. I'm refactoring I've got a microservices simulator that runs in my head right now, and I need to get it out into the code so that other people can play with this thing that I'm dreaming up. So that's kind of a fun project for me, and I partly learned Go just so I could read some of the code I was seeing come by, but I'm finding it to be kind of a fun language for building fairly complicated things in. Other languages, I think somebody said, in the end, anything that can be written in JavaScript will be written in JavaScript. Some comment like that. So I'm actually finally learning JavaScript and sort of tinkering around with that. I need to build the user interface for my simulator somehow, and so I'm playing around with D3 and trying to get my head around how that works. And then because I was playing with Lambda, I actually had to learn Node. So I've got sort of I half know how to use a couple of different things in JavaScript land and can sort of read it now, but I wouldn't say that I'm particularly comfortable in that language yet. And that's where it's going. In terms of other interesting languages, a bunch of things in Scala, although Java 8 is sort of making a bit of a comeback for people that want a bit of Java. And there's a company called SumAll in New York that I've spent some time with, and they actually have some production code running in Haskell. So that's kind of bleeding edge, I think. And Clojure is another language that's got interesting supporters. A lot of the best programmers, some of the best programmers I know won't write anything except Clojure. So it's one of those sort of very biased things where they're just off in that world and they're very happy and productive and they don't want to touch anything else. So.
Yeah, I had a similar thought about Go. I haven't written it myself, but almost every programmer I respect right now writes something in Go, so I think that says a lot.
Mm-hmm.
All of our systems, particularly the back end and our agents, anything that needs performance and concurrency are written in Go with VividCortex, partly because of those characteristics. But there's another important one, which is that Go executables compile to a single binary that is distributable without any dependencies going along with it, so it's statically linked. And in that way, it's almost like the containerization of the binary. It makes deployment a completely different story. And it's very, very helpful. We're writing even small scripts and so forth that we would otherwise maybe use shell or something like that for. We're writing those in Go now because of that characteristic, among others.
There's a downside to that, though, which the Docker team are currently having a problem with, which is that they want to build a pluggable extension API for Docker, and there is no way to deliver it using Go. Right? If you do something in Java, you can modify the jar files. There's ways of gluing things into the side of a thing. If you've got dynamically linked, you can dynamically link in some new function. So the problem with that is that they're having to build an out-of-process link, and they're looking at various techniques. You either do calls between them or do some shared memory or something, but it's a relatively unnatural act to build an extendable Go program, and so just sort of pay attention to that if you're thinking about upside and downside of different technologies.
That's a great point. I do know one of the presenters at Monotorama last year from Mozilla. What is it called? Heka. They actually they have a pluggable architecture, but everything has to be compiled in. It's not pluggable at runtime. So that is a limitation that I've seen come up, although not for us here at VividCortex. Yeah. And speaking of Monotorama, I wanted to close out with a few minutes of the conferences that we're participating in, organizing, and anticipating going to in the next few months or so. Jason, do you want to lead off with Monitorama?
Sure. Yeah, obviously, I'm biased, but that's because it's an awesome conference. So Monitorama it's a monitoring conference. It started as a something focused exclusively on open source monitoring tools. It's still largely around that, but it's about the bigger picture of monitoring and tooling. So we actually just announced our first batch of speakers this morning. We've got a lot of folks from Stripe and Netflix and other places. So I'm very excited about it. It's going to be in June, so and back in Portland again. So I hope I see everybody out there.
I was muted. That was an awesome show. I was there. It was one of the better conferences I've been to. Nathan, you're involved in a couple of things coming up too.
Yeah, in just a couple of weeks here, I'll be over in Ghent in Belgium for Configuration Management Camp, which is a great conference that's really about bringing all of the various communities around configuration management together. So there will be, of course, a main track, but then there will be community rooms where you can go and learn about Chef, learn about Puppet, learn about Ansible, and get to interact with those communities, which is it's a really pretty unique experience to get to have that sort of cross-pollination, if you will. Additionally, ChefConf is coming up at the end of March, beginning of April, which, of course, I'm also pretty biased about. Is an awesome conference as well. And then we're in the early planning stages for bringing a DevOps Days to the DC area. It's looking like mid-June-ish is when the conference will be held, but if you can just watch our progress on that on DevOpsDays.org.
And Adrian, your conference is twice a week, aren't you?
Yeah, I did 40 public conference presentations last year. I made a list of them at the end of the year, and I thought that was kind of excessive, but this year looks like it's being the same. I generally try to not do the same conference one year to the next so that I move it around a bit, because they tend to conflict with each other, and also because you don't want to be the guy that you see every year doing the same kind of stuff. So making an exception for Monitorama, I'll be there again this year. That was one of the excellent conferences last year, so I was very happy at that. Happy to see that. I have to, if I can get my Go program built, that's what I'm doing with that, because I think I can build something you can use for simulating large-scale networks and then using that for testing monitoring tools. So that's kind of one of the bits that's in my head that hasn't happened yet. So maybe by June I'll have built enough of that to actually demo it. In a couple of weeks, I'm going to be in Austin for an IEEE ACM conference, more looking around some of the academic space here. It's called the ICPE, the International Conference for Performance Engineering. And then in March, I'll be O'Reilly doing a new conference in Boston called the Software Architecture Conference. So go look at that on the O'Reilly side. I was on the program committee for that, looking at reviewing some of the talks. So that's going to be an interesting conference to sort of keep a track of and see how that develops with the O'Reilly team.
Excellent. For myself, I'm looking forward to GopherCon, which was one of the best conferences I went to last year. It's about the Go language, and it will be in Denver, July 7th through 10th. And then every year, Velocity is one of my favorite conferences to go to. Perhaps that's so mainstream and large that I'm. It's almost like mentioning a boy band, that you like a boy band's music, isn't it? Yeah. But I still love Velocity. There's a reason it's so popular.
Somebody yesterday was talking about the John Allspaw talk at Velocity, that second ever Velocity, where they was talking about 100 releases a day at Flickr. And I said that it was like, I was actually in the room when that talk happened, and it's like you were actually there when it happened. That's kind of one of the birth of DevOps moments that happened. Cool.
Yeah. Well, thank you, everyone. It's been a real pleasure having you, and thanks everyone for joining us. We will post the video up online, and follow VividCortex's blog and VividCortex's Twitter account to learn more about when the video is available. Of course, if you were here, I don't know why you would want the video, but tell your friends about it, and we will see you on the next one. Thanks a lot, everyone, and bye for now.